di by dt protection. The thyristor requires minimum time to spread the current conduction uniformly throughout the junction. If the rate of rise of anode current is very fast compared to the spreading velocity of the turn-on process, a localized hot spot will occur due to high current density and the device may fail as a result of excessive temperature. The practical device must be protected against high di by dt. And this is an example of thyristor circuit with di by dt limiting inductor. Under steady state operation, dm is going to conduct when thyristor T1 is off. When thyristor is on or fired, when dm still in conduction, di by dt very high and limited only by sway inductance of the circuit. In practice, the di by dt is limited by adding a series inductor Ls. We know that Vs equals to Ls di by dt, from which we can say that the current is not going to change across an inductor instantaneously. So the inductor is used to limit the current. Then from this, di by dt is equals to Vs by Ls, where Ls is the series inductance including any stray inductance, and this is also known as a series snubber. dV by dt protection. If the switch S is closed at t equals to 0, a step voltage, which means it's going to increase instantaneously at t equals to 0, will be applied across the thyristor T1. And dV by dt may be high enough to turn on the device. The dV by dt can be limited by connecting a capacitor across the thyristor. When the thyristor T1 is turned on, the discharge current of a capacitor is limited by connecting a resistance Rs in series with Cs, and this Rs and Cs series circuit is known as snubber circuit. The voltage across the thyristor will rise exponentially now. The circuit dV by dt can be found approximately from the formula, that is 0.632 Vs divided by a tau. A tau is nothing but the snubber circuit time constant. This can be written as dV by dt is equals to 0.632 Vs divided by tau is Rs Cs. And this value can be found if we know the dV by dt ratings of the thyristor, and it is mentioned by the manufacturer. The value of Rs is found from discharge current. Rs equals to Vs by ITD. It is possible to use more than one resistor for dV by dt and discharging. The circuit is shown. A dV by dt is limited by R1 Cs and R1 plus R2 limits discharge current, such that the thyristor discharge current ITD equals to Vs divided by R1 plus R2. The load can form a series circuit with a snubber network as shown. Now the damping ratio delta for the second order equation is given by alpha by omega naught, which is given by Rs plus R by 2 square root of Cs by Ls plus L, where Ls is the stray inductance and L and R are the load inductance and the resistance respectively. Now to limit the peak voltage overshoot applied across the thyristor, a damping ratio should be maintained between 0.5 and 1. Usually the load inductance L is high, then Rs will be high and the Cs will be small to retain the desired value of damping ratio. A high value of Rs will reduce the discharge current and a low value of Cs reduce the snubber losses. Once the damping ratio is known, Rs and Cs can be found. The same RC network or snubber is normally used for both dV by dt protection and to suppress The transient voltages due to reverse recovery term.